Hello everyone. Today we are going to learn about the converse of basic proportionality theorem, and we are going to prove this theorem. So the statement of the theorem is that if a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. To prove it, we'll draw a triangle ABC and a line segment intersecting side AB at P and AC at Q, such that we have been given here that AP upon PB equals to AQ upon QC. And we need to prove that PQ is parallel to PC. Now to prove it, we'll take the given statement, which is AP upon PB equals to AQ upon QC, and we will take the reciprocal of it, which will be PB upon AP equals to QC upon AQ. Now we are going to add 1 to both sides, and on taking LCM, we'll be getting the value of the statement as PB plus AP upon AP equals to QC plus AQ upon AQ. When we add PB plus AP, we'll be getting as AB, and when we add QC plus AQ, we'll be getting the side AC. So we'll be getting AB upon AP equals to AC upon AQ. Now we'll take triangle APQ and triangle ABC, and we know that AB upon AP equals to AC upon AQ, which we have just proved, and in these two triangles, angle A is common, so we can say that triangle APQ is similar to triangle ABC by SAS criteria. So we can say that angle APQ equals to angle ABC, which are corresponding angles, and so we can say that PQ is parallel to BC as corresponding angles are equal. And this is how we can prove this theorem. Thank you. Take care everyone.